Okay, we're on Unit 5, assignment number 7's notes, as you can see. Here's what I need you to do. The first three equations under the category in the notes for putting an equation in perfect square form, cross out the three equations like I have done, and underneath each one of the equations, go ahead and write the equations that I've written. X squared plus 6x plus c, x squared minus 10x plus c, and x squared plus 12x plus c. Okay, and what we're going to do is we're going to learn how to put equations in what we call perfect square form here. Okay, and perfect square form is a particular type of equation that we're going to use in order to solve equations in the next section here. Okay, and it's a pretty simple process of putting an equation in what we refer to as perfect square form. And here's how you put equations in perfect square form. You take the number, the value, just the number in front of the x, which in the first example is a 6. You cut that number in half. In other words, you divide it by 2, which is going to be 3. And then you take that number and you square it. So 3 squared is equal to 9. So what that tells me is that my equation in perfect square form is going to be x to the second power plus 6x plus 9. Okay? And as you can see, what I've essentially done is I took the original equation and I just found the c value. Okay, moving on to the second equation, we are going to put this equation into perfect square form. So what we do is we take the number in front of the x, which is negative 10. You cut it in half. In other words, you divide it by 2. Sorry, you guys, my program is having problems right now. You divide it by 2. That is equal to negative 5. And then you take that and you raise that number to the second power. Negative 5 to the second power is equal to positive 25. So that means my equation that I started with, which had the variable c, in perfect square form becomes x squared minus 10x plus 25. Okay, there we go. Last example, we have x squared plus 12x plus c. We're going to put this equation in perfect square form. So we're going to take the 12. You always take the number in front of the x. You always divide it by 2 or cut it in half. That is 6. And after that, to put an equation in perfect square form, then you take that, after you cut the number in half, you take that answer and you put it to the second power. So 6 to the second power is equal to 36. So that means that my equation, x squared plus 12x plus c, in perfect square form becomes x squared plus 12x plus 36. Okay, so there's how we put equations into perfect square form. Then we go down to the next part of the problem, or of the notes, where this next part, what we're going to do is we are going to take, we're going to put an equation in perfect square form, and then we're going to solve the equation, aka we're going to be completing the square. Okay, and here's how we go about putting an equation in perfect square form. We just knew how to do that, but then we're going to solve the equation, which is we're going to use a process called completing the square. So we have x squared plus 8x minus 9 equals 0. Well, if you notice that this minus 9 right here, that negative 9, that part of the equation is actually where the c is supposed to be. Okay, so the first thing that I need to do in this problem is I need to take my value, negative 9, and I need to get rid of it because that's where my c value is supposed to be. And the way that I get rid of it is I'm going to add 9 to both sides of the equation. When I add 9 to both sides of the equation, what that does is it changes my equation to x squared plus 8x is equal to positive 9. Now, when you get rid of that number where the c value is supposed to be, so we are supposed to have a c value right there, okay? And when you get rid of that number, what you want to do is, and I'm going to erase the c, you do not have to, well, I'm probably not going to erase it because my computer program doesn't like me right now at all. We're having troubles. But what we're going to do is we're going to figure out what number goes where that c value is, okay? And we're going to do that by putting the equation in perfect square form. So the way to do that is I take the number in front of the x, which is the 8. I divide it by 2. That is equal to 4. When I divide it by 2, I get it equal to 4. I square that. 4 squared is equal to 16. So that means my equation becomes x to the second power plus 8x plus 16 is equal to 9 plus 16. And if you notice, what I did in my equation was I added the c value, which was 16, but you have to keep the equation balanced, and the way you keep the equation balanced is you have to add the same amount to the other side of the equation. Okay, so now here's what I'm going to do. I'm now going to take my x squared plus 8x plus 16 part of the equation. So I'm going to take the left side of the equation and I'm going to factor it. And the way that I'm going to factor it is that's where I'm going to incorporate the area model and the diamond problem to factor, see what the factors are of x squared plus 8x plus 16. Okay, so drawing out my area model, I put the x squared in the top left. I put the 8x in the bottom of the diamond problem. I put the 16 in the bottom right of the area model. I get 16x squared up at the top of the diamond problem. And then I've solved the diamond problem. So I'm looking for two values that multiply to make 16x squared, add to make 8x. That would be 4x and 4x. I move the 4x and the 4x over to my area model. And then I fill out the outside top. I'm going to have an x and an x on the outside top and the outside left, because x times x is x squared. Then I fill out the outside top, which would have to be a positive 4, because 4 multiplied with x is 4x. Excuse me. I fill out the outside left, which would also have to be a positive 4. So you could see my factors are x plus 4 and x plus 4. And the way that you write that is that you're going to take, so what we're going to do is now, we use the area model in the diamond problem, and now my equation becomes x plus 4 in parentheses to the second power is equal to 25. Okay, and I got to 25, if you're a little confused on that, by going 9 plus 16. So 9 plus 16 is 25. X squared plus 8x plus 16, it factored into x plus 4 in parentheses to the second power. Okay, now I solve this equation. So in order to solve this equation, I need to get rid of the exponent of 2, and I need to get rid of the plus 4 to solve for x. I need to get x by itself. So the first thing I'm going to get rid of is that exponent of 2. And the way you mathematically get rid of an exponent of 2 is you take the square root. And you have to take the square root of both sides. Okay, so when I take the square root of the left side of the equation, that square root symbol cancels out that exponent of 2, leaving me with x plus 4 is equal to, and then the square root of 25, remember, it is 5, but it's not just positive 5, it is negative 5 as well. So the square root of 25 is going to be positive 5 or negative 5. And we represent that by putting that plus and that minus symbol in front of it. Continuing to solve this problem, I'm going to subtract 4 from both sides of the equation. That would cancel out the 4's on the left side of the equation, leaving me with x is equal to, and then I work this problem out, okay? So I'm going to get two answers. One of my answers is -9, or my other answer is going to be +1, all right? Now, how did I get -9 for one of my answers? The way I got the -9 is I took the -5 part of the problem and I -4 from it. -5 minus 4 is -9. How did I get +1? I took the +5 portion, -4 is +1, okay? So this is an example of how we use what we call completing the square. All right, let's move on to the second example. X squared minus 14x plus 49 equals 0. So the first part of this problem is this 49 is supposed to be where the C is. Okay, so I have to get rid of the plus 49. So I'm going to minus 49 from both sides of the equation. When I do that, I get a brand new equation. And the brand new equation is x squared minus 14x plus C, I'm putting that C where that plus 49 used to be, is equal to -49. Okay, now I'm going to put the equation in perfect square form. So I'm going to have to find the value that goes for C. The way that I do that is I take the number in front of the x, which is -14. I divide that number by 2. -14 divided by 2 is -7. Then I take that to the second power. -7 to the second power, or -7 squared, is equal to 49. Okay, and now what that does is that makes my equation in perfect square form, x squared minus 14x plus 49 equals -49. But since I added a 49 to the left side of the equation, to keep the equation balanced, I have to add a 49 to the other side of the equation. Think of an equation when we do this step, when you add 49 to both sides of the equation. It's like a teeter-totter, where if you add 49 to one side of the teeter-totter, the equation, then to keep it balanced, you have to add the 49 to the other side. Now, I'm going to take this equation right here, x squared minus 14x plus 49, and I'm going to factor it. So I'm going to draw my area model and my diamond problem. And I factor the x squared minus 14x plus 49. X squared goes in the top left area model. Minus 14x goes in the bottom of the diamond. 49 goes in the bottom right of the area model. 49 multiplied with x squared makes 49x squared. So I put that at the top of my diamond problem. And then I figure out what goes in the left and the right of my diamond problem. Okay, so I'm just going to pause the video for a second. And then you guys figure out what goes in the left and the right of the diamond problem. All right. I heard you guys saying it, by the way, as you were working it out. And if you did work this out, you indeed found that the left and the right of the diamond problem are going to be -7x and -7x. And once my crazy program allows me to write, there we go. It's a -7x and a -7x. You take the -7x and you take both of them. You fill in your inside of your area model. Now we fill in the outside top and left of my area model. I'm going to have an x and an x because x times x is x squared. I follow the x on the outside left over to the -7. I would have to multiply -7 to make -7x. So my top of my area model is x minus 7. The left side of the area model is also going to be x minus 7 because -7 times x is also -7x. Okay, so if you notice when I factored it, I have an x minus 7 and an x minus 7. So that tells me my equation, which is x squared minus 14x plus 49, becomes x minus 7 in parentheses to the second power is equal to 0. Now, once again, the way I got 0 was I I added negative 49 plus 49 is 0. Okay, and I got the x minus 7 in parentheses to the second power by factoring the trinomial x squared minus 14x plus 49. Now I'm going to solve this equation over here. X minus 7 to the second power equals 0. I have to get rid of the exponent of the 2, and I have to get rid of the minus 7. I'm going to get rid of the exponent of 2 first, and the way we get rid of an exponent is we take the square root of both sides of the equation. Okay, so taking the square root of both sides of the equation, the left side of the equation, the square root symbol, cancels out the exponent of 2, leaving me with x minus 7 is equal to, and the square root of 0 is 0. Okay, and for 0, it's not plus or minus. It's just 0. Okay, continuing to solve, I add 7 to both sides of the equation, and for this particular equation, I get the solution of x is equal to 7. All right, so x is equal to 7, excuse me, so this means there is only one solution to this problem. Okay, so there's 2 examples of how to use, how to put an equation in perfect square form, and then how to solve that equation using the strategy or the steps that we use. It's called completing the square.